Hi guys, this video is going to go through Chapter 1, Sections 1. There'll be some other videos for Sections 2 and 3 if everything works out. So we're going to go ahead and start on page 4. So I'm going to go ahead and read it aloud. Make sure you're following along with me. I'll kind of tell you. Remember, this section goes along with the worksheet we're going to do called Directed Reading A worksheet. So just remember that that's why we're reading this, to complete that and to understand some things about minerals. So you may think that all minerals look like gems, but in fact most minerals look more like rocks. Does that mean that minerals are the same as rocks? Well, not really. So what's the difference? For one thing, rocks are made of minerals, but minerals are not made of rocks. A mineral is a naturally formed, inorganic solid that has a definite crystalline structure. Mineral structure. By answering the 4 questions in Figure 1, you can tell whether an object is a mineral. If you cannot answer yes to all 4 questions, you do not have a mineral. 3 of the 4 questions may be easy to answer. The question about crystalline structure may be more difficult. To understand what crystalline structure is, you need to know a little bit about the elements that make up a mineral. Elements are pure substances that cannot be broken down into simpler substances by ordinary chemical means. All minerals contain one or more of the 92 naturally occurring elements. So this is Figure 1. Make sure that you see those 4 questions. Atoms and compounds. Each element is made up of only one kind of atom. An atom is the smallest part of an element that has all of the properties of that element. Like other substances, minerals are made up of atoms of one or more elements. Most minerals are made of compounds of several different elements. A compound is a substance made of 2 or more elements that have chemically joined or bonded. Halite, NaCl, for example, is a compound of sodium, Na, and chlorine, Cl, as shown in Figure 2. A few minerals such as gold and silver are composed of only one element. A mineral that is composed of only one element is called a native element. Crystals. Solid geometric forms of minerals produced by a repeating pattern of atoms or molecules that is present throughout the mineral are called crystals. A crystal shape is determined by the arrangement of atoms or molecules within the crystal. The arrangement of atoms or molecules is in turn determined by the kinds of atoms or molecules that make up the mineral. Each mineral has a definite crystalline structure. All minerals can be grouped into crystal classes according to the kinds of crystals they form. Figure 3 shows us how the arrangement of atoms in gold may form cubic crystals. So this is going to take you through the process. Keep in mind that there's going to be some definitions here that's going to help you with your worksheet. So remember, you're not just looking at this text, but you're looking at all of the illustrations, the figures, and the definitions. Next page, page 6. 2 groups of minerals. The most common classification of minerals is based on chemical composition. Minerals are divided into 2 groups based on their chemical composition. These groups are the silicate minerals and the non-silicate minerals. Silicate minerals. Silicon and oxygen are the 2 most common elements in the Earth's crust. Minerals that can contain a combination of these 2 elements are called silicate minerals. Silicate minerals make up more than 90% of the Earth's crust. The rest of the Earth's crust are made up of non-silicate minerals. Silicon and oxygen usually combine with other elements, such as aluminum, iron, magnesium, and potassium, to make up the silicate minerals. Some of the more common silicate minerals are shown in Figure 4. So here's some other common ones: quartz, mica, and feldspar, I believe. So non-silicate minerals. Minerals that do not contain a combination of the elements silicon and oxygen form a group called the non-silicate minerals. Some of these minerals are made up of elements such as carbon, oxygen, fluorine, and sulfur. Figure 5 on the following page shows that the most important cases of non-silicate minerals. So keep in mind we still have some definitions over here that's going to be helpful. And figure 5 is going to be helpful on your assignment as well. You're going to definitely want to read into these. I'll go ahead and read them out loud, but that's going to be the end of section 1. So we have native elements. Are minerals that are composed of only one element. So some examples are copper, which is represented by Cu, gold, Au, and silver, Ag. Native elements are used in communications and electronics equipment. Carbonates are minerals that contain combinations of carbon and oxygen in their chemical structure. We use carbonate minerals in cement, building stones, and fireworks. Halides are compounds that form when fluorine, chlorine, iodine, or bromine combine with sodium, potassium, or calcium. These minerals are used in chemical industries and in detergents. Oxides are compounds that form when an element such as aluminum or iron combines chemically with oxygen. Oxide minerals are also used to make abrasives, aircraft parts, and paint. Sulfites are minerals that contain sulfur and oxygen. So SO4. Sulfates are used in cosmetics, toothpaste, cement, and paint. Sulfides are minerals that contain one or more elements such as lead, iron, or nickel, combined with sulfur. Sulfides materials are used to make batteries, medicines, and electric parts. So just a reminder, this figure 5 is going to be very helpful along with figure 4. Remember, highlighted words can help you along with any illustrations. So that was section 1, pages 4 through 7. Go ahead and see if you can fill out your directed reading A worksheet, and go ahead and find section 2.